Welcome to this presentation on instructional design principles. My name is Allison, and I will be providing an overview of 3 instructional design principles over the course of the next few minutes. The objectives for this presentation are that by the end of the lesson, you will be able to explain the coherence principle, provide an example utilizing the coherence principle, explain the signaling principle, provide an example utilizing the signaling principle, and explain the spatial contiguity principle and provide an example utilizing the spatial contiguity principle. The coherence principle enhances learning by removing extraneous material. Extraneous material contributes to cognitive load and can overload the visual channel, the verbal channel, or both. If either channel is overloaded due to processing extraneous material, this means that the learner has less capacity to process the essential material and are therefore less likely to really learn the most important aspects of any given set of material. As an instructional designer, you can incorporate the coherence principle by eliminating non-essential printed words, illustrations, videos, narration, music, etc. Imagine that you are a student learning about the rock cycle, and the instructor is explaining how metamorphic rocks become igneous rocks using the image shown here on the screen. You need to concentrate on metamorphic rocks and what happens to them so that they become igneous rocks. However, there are so many colors, arrows, fonts, shapes, words, etc., that it's extremely hard to follow the process. You end up having to process all of this extra information just to see that metamorphic rocks melt into magma, the magma cools, and that becomes an igneous rock. Now imagine the same situation, except the instructor is explaining the process using this image. All of the extraneous information has been removed. As a student, you don't have to process the non-essential information that is unrelated to the task at hand. Instead, you can concentrate on a simple process. Metamorphic rocks melt into magma, the magma cools, and an igneous rock is formed. It doesn't look as artistic, but the student's learning is enhanced because the chance of experiencing cognitive overload has significantly decreased. The signaling principle enhances learning by highlighting the essential material. This principle is also sometimes referred to as the cueing principle, and that is because the idea behind it is that either cues or signals are added to the material to help highlight and organize the essential information. This helps the learner process that information and thus reduces their cognitive load. It also helps them focus on the essential while ignoring the non-essential information. As an instructional designer, operating under this principle, you are not adding or removing any information, rather just calling out the essential and most important aspects utilizing techniques such as bold text, underlines, spoken emphasis, outlines, shapes, arrows, headings, etc. Imagine that you are a student receiving instruction on how to use PowerPoint SmartArt to create a diagram showing the rock cycle. The instructor tells you to first click on SmartArt under the Insert tab, then click on Cycle, and then once you have selected your diagram, click OK. You may have trouble following along because you are taking in all of the options under tabs, the available buttons, and graphic choices. You have to look at everything shown on the screen and focus in on what the instructor is telling you while simultaneously weeding out the irrelevant items you see on the screen. Now imagine you receive the same set of instructions for using SmartArt to create a diagram about the rock cycle, but these signals have been added. Chances are you'll be able to follow along with the instructor more easily, grasp the process quickly, and all the while are able to more easily focus in on the relevant parts of the screen and ignore the irrelevant aspects. This is the benefit that the signaling principle provides by highlighting the essential information. The spatial contiguity principle enhances learning by presenting related material close together. The opposite of spatial contiguity is known as separated presentation, in which the corresponding words and pictures are presented relatively far away from one another. Spatial contiguity is preferable to separated presentation because it reduces the learner's need to scan back and forth and thus reduces cognitive load. It also allows the visual channel to focus on important information all at once rather than having to piece it together. Imagine you are reviewing a diagram about the rock cycle where you have to look at the corresponding letter in the key and then put it together yourself. As the student, you are unnecessarily utilizing cognitive capacity to understand the diagram with the help of the chart. You are scanning back and forth between the key and the diagram unnecessarily. In this case, the key and diagram are located relatively close to each other. The issue would be even further exacerbated if the diagram and key were located further apart, such as on different pages of a printed material or different slides or screens of digital media material. Now imagine you are viewing the same diagram, but the parts of the cycle are labeled directly on the diagram instead of utilizing a key. The cognitive load is reduced because as a student, you are not required to scan between the images and words and put it together. This enhances learning by reducing extraneous processing, reducing load on the visual channel, and opening up cognitive capacity to concentrate on the essential information. In conclusion, during this video, we discussed the following instructional design principles: coherence, which says we should eliminate extraneous information; signaling, which says we should highlight essential information; and spatial contiguity, which says we should present related materials close together.